Welcome back to Larry's Classroom. Today we're going to be learning about percentages. Basically, percentage is simply a fraction with a denominator of 100. Let's take some examples. Let's say we have 25%. Well, we could write that as a fraction, 25 100ths. And then, of course, we converted that to a decimal. If we did the division, the 25 divided by 100, we would end up with 0.25. We see that we have 25%, the 25 in the numerator, the denominator of 100. We did the division, 0.25, which also, from our discussion of decimals, you remember that this was tenths and hundredths, two decimal place. We got two decimal place, indicates two zeros, 100. 100%, we'll do a few more examples here, equals 100 in the numerator, a denominator also of 100, and when we divide 100 by 100, we end up with 1.00. Now we put the two zeros on here to indicate that it's hundredths. 115%. We'll do another example. We'll do several examples here, and we'll go on and talk about how to use percentages. Again, 115%, 115 in the numerator of our fraction, 100 in the denominator of our fraction, which is basically the definition of what percent means. We do the division, we end up with 1.15. That's the decimal equivalent of 115%. 1.5%, much smaller amount. That is basically 1.5 over 100. The 100 in the new denominator, 1.5 in the numerator. If we do the we can rewrite this as 1.5. We want to get rid of the fraction on the top. We can do that. We have it times 10 over 100 times 10 gives us 15 over 1,000. Now this allows us to do the division very simply. These are all equivalent fractions. This is no longer, it's not 15% because we no longer have 100 in the denominator, but being these are equivalent fractions, the decimal result doing the division will be the same for each of them. Now if we take this 15, divide it by 100, we could do it with our calculator, but we can also do it by moving the decimal place 3 places to the left. 1, 2, 3. So then put this leading 0 to help our eye spot the decimal place. So that's 0.0015. You're right. What have I missed up here? 1,000. Oh, okay. I moved my decimal place one too many here. I want to move my decimal place 3, but I want to start right here. 1, 2, 3. So we only have to add a single 0. Equals 0.015. So 1.5%, 1.5 over 100 times what I like to call a fancy 1. Don't change the value. Equivalent fraction, 15 over 1,000. We end up at 0.015. But we also notice if we looked at it as hundreds, it would be 1.5 hundredths. And in here, it'd be 115 hundredths, because the second decimal point gives you where the hundredths is at with your decimal fractions. This would be 100 hundredths. This would be 25 hundredths. Again, 2 decimal places gives you where the hundredths column is of your decimal fraction. And this one here, 0.015, again, right here gives us the hundredths amount of the decimal fraction, and we have another half, or another 0.5. That's why it becomes 1.5. So there are a couple of rules to change it. I'm going to erase that. Well, I'll leave it for percent to decimal. Percent to decimal. Move decimal point two places to the left. To the left. Which is equivalent to dividing by 100. 100. And we took this 25%, decimal place right there, 1, 2, 2 places left, gave us the 0.25. Took the 100%, moved 2 places to the left, 1, 2, gave us 1. The 115%, 1, 2, gave us 1.15. The 1.5%, 1, 2, gave us the 0.015 as a decimal version. We have the percent here, the decimal here. We move from here to here by dividing by 100, which it can be done by moving the decimal place 2 places to the left. Another rule to go from decimal to percent, move the decimal place, point, move the decimal place 2 places to the right. To the right. Which is multiplied by 100, the equivalent of multiplying by 100. So, if we take our decimal version, 0.025, if we move the decimal place 2 places to the right, it becomes 25, which gives us our percent. Here we had a decimal version of 1.00. We move our decimal point 2 places to the right, which gives us 100%, the equivalent of multiplying by 100. 1.15 was our decimal version. We moved the decimal place 2 points to the right, 2 places to the right, which is equivalent of multiplying by 100. So our 1.15 decimal becomes 115%. Now way over here we had our very small decimal number, 0.015. Again, we move our decimal place 2 places to the right, which becomes 1.5, the equivalent of multiplying by 100. We end up with 1.5%. So the things to remember is that percent means hundredths, means the denominator of 100th. To convert from percent to decimal, divide by 100, move the decimal place 2 places to the left to make the number smaller. To convert from decimal to percent, move the decimal place 2 places to the right, multiply by 100, make the number larger. Now we're going to take some fractions, and we're going to change each fraction to a percent and then to a decimal. So, 3/4. To be a percent, we want to get a denominator of 100. So, 4 times 25 will be 100, correct? That makes our denominator 100. When we multiply the denominator by 25, we need to do the same thing with the numerator. 3 times 25. And if we multiplying fractions, multiply across the numerator, multiply across the denominator, across the top, across the bottom, if you want to remember it that way. 3 times 25, numerator 75. 4 times 25, 100 for denominator. Now that we have a denominator of 100, that is the definition of percent. So this equals 75%. Our 3/4 equals 75%. Now remember to go from percent to decimal. We move the decimal place 2 places to the left, which is basically divide by 100. So that gives us a 0.75 as the decimal version of 75%. We do a few examples because we want to make sure that everyone understands this. We're going to do another one. 9/16. Now this one isn't quite so slick and easy to convert to a denominator of 100, so we're going to do the division first. If we do the division with a calculator, we end up with 0.5625. So we went directly to the decimal version. And remember, to go from decimal to percent, we multiply times 100, which is move the decimal place 2 places to the left. So when we do that, we end up with 2 places left, we end up with 56.25%. So we had a decimal of 0.5625, we have a percent of 56.25. Now, let's see. Notice that our hundredths part matches up with our percentage part. The hundredths columns, the hundredths portion, shall we say, of our decimal, the first two digits to the right of the decimal place match up with our whole number portion of our percent. And beyond that is our fractional portion of our percent. Do a couple more of these. The goal here is to understand the way that decimal and percent convert back and forth and relate to each other. 6/5. Now this one, a little bit easier to get the 100 on the bottom, because 5 times 20 is 100. So we can also go 6 times 20. So we've multiplied by 20/20, multiplying by the equivalent of 1. We're not changing the value of our fraction, so we'll get an equivalent fraction. Well, 6 times 20, 120. 5 times 20 is 100. So the 6/5, you notice this is an improper fraction. It's slightly greater than 1. And the same thing here, 120 over 100. So we have 3 equivalent fractions. 6/5, 6 times 20 over 5 times 20, 120 over 100. But remember, the denominator of 100 is the definition of what a percent means. So this is, in fact, 120%. And of course, the rule, to go from percent to decimal, we divide by 100. And we do that by moving the decimal place 2 places to the left. So instead of 120, we end up with 1.20. And we see again here the 120 100ths matches up with the 120%. That's the 100ths part. That matches up with 120%. Decimal version, percent version. We did the division to get the, and then we did a fraction, and then we made the denominator 100. That gave us percent. We could have done the division. We would have got 6 over 5 equal 1.2. And then we could have moved our decimal place 2 places to the right to go from decimal to percent, which would have given us the 120%. So it's consistent. We'll do one more here and then we'll look at something else. 3 over 200. There's a fraction. Okay, we want to figure out what this is in percent first. Well, we want a denominator of 100 for percent. So we can go 3 times 1/2 over 200 times 1/2. 1/2 times 200 will equal 100. So we multiply the numerator and the denominator by 1/2, still multiplying by the equivalent of 1, not changing the value, still an equivalent fraction. Well, 3 times 1/2 is 1.5. 200 times 1/2 is 100. So what have we got here? We got 1.5 over 100. 100 denominator being the definition of percent. So it equals 1.5%. And of course, to go from percent to decimal, we divide by 100. So we move the decimal place 2 places to the left. And after we do that, we end up with 0.15. Oh, there, right? Let's move this over here. We got a little more room to work. 1.5%. Move the decimal place 1, 2. We have to add a 0 to do that. We'll add the leading 0 just to make things make your eye focus in on the decimal point better. So we end up with 0.015 for the decimal part. And let's change this back to the percent. 1.5%, 0.015. And the decimal place was here. We moved 2 places to the left. The decimal place is here. If we want to go back to percent, 2 places to the right. Multiplying by 100 moves us to 1.5%. And when the decimal place was here, we divided by 100, 2 places to the left, got us the decimal portion. So the key here, 100, 100, 100. We didn't do that here because there's no whole number. Well, it wasn't here too, but it was an easy one to do. It would be more complicated to figure out what the multiplier to turn 16 into 100 was. So we decided to do the division with our calculator first and work that way to get our percent. And we showed how going back and forth from percent to decimal, 2 places to the left, which is dividing by 100, decimal to the percent, decimal plate 2 places to the right, which is the equivalent of multiplying by 100. Now we're going to do some more stuff like this. We're going to change some percents into fractions. So we have a percent, a point. We have 85%. No, we have some decimals that we're going to change to percent and then to fractions. So we have 0.85. That's the decimal. Remember the rule. To go from decimal to percent, we multiply by 100, move the decimal place 2 places to the right. So after we do that, 1, 2, we have 85%. Now if we want to make that into a fraction, well, percent means a denominator of 100, so we can just go 85 over 100. Of course, we like to reduce the fraction to lowest terms. Both of these have a factor of 5. So 87 is 17 times 5, and 100 is 20 times 5, which when we cancel out the 5s, we end up with 17 over 20, which is in lowest terms because 17 is prime. The only factors are 1 and 17. Well, there is no 17 that divides into 20, so we found that 85%, or 0.85 was 85%, converted to a fraction, reduced to lowest terms. 17 20ths is 0.85. It's also 85%. Another fraction. We'll do another one. We got about 4 of these I guess I want to go through. 0.40. There's our decimal. You remember by now we multiply it by 100 to get percent. 2 decimal places to the right, which so it's 40%. Now we want to find it as do it as a fraction, put that into lowest terms. Well, the definition of percent is a denominator of 100, so that's 40 over 100. Both of these are divisible by 20. 40 is 2 times 20. 100 is 5 times 20. So we cancel out the 20s, gives us 2/5. So 0.40 is 40%, converted it to a fraction by putting it over 100, reduced the fraction by factoring and canceling, 2/5, 40%. One more decimal number. So to convert that to a percent, we multiply times 100, which means we move the decimal place 2 places to the right, which puts us to 140. So that's 140%. We want to make it into a fraction. We'll put the percent over 100. 140 over 100. There, now it's in fractional form. We like to make our fractions in least terms, so we do that by factoring the top and the bottom, which the numerator and the denominator, which factors into 7 times 20 and 5 times 20. And now we can cancel the like factors that are in the numerator and the denominator, which is the 20, which basically gets rid of a multiply by 1. That leaves it as 7 over 5. There's the reduced fraction. 7 and 5 are actually both prime. We know we have no more factors that we can cancel out. But as I told you in an early lesson, you do not have to have a prime number in the numerator or the denominator in order to have a fraction in lowest terms. You just have to have 2 numbers, a number in the numerator and a number in the numerator and a number in the denominator that have no like factors. They do not have to be prime, but if one of them is prime and the other one is not a multiple of that prime number, then you know that you're there. But being they're both prime, very easy to see that we're lowest terms there. And you'll note this is what we call an improper fraction. Really, an improper fraction is just a fraction whose equivalent value is greater than 1. And you can see that 1.4 is greater than 1. And 140% is greater than 1. Because 100% is 1, numbers greater, any percent greater than 100 is greater than 1. So we're going to do one more of these type of problems. One more decimal number, 0.125. We want to convert that into a percent and then to a fraction. Well, decimal to percent, we multiply by 100, which is simply move the decimal place 2 places to the left. So we have 12.5%. Now, percent means a denominator of 100, so we can simply write this as 12.5 over 100. Now we want to, first thing, let's get rid of the fractional number in the numerator. We do that by going 12.5 times 10 over 100 times 10. Well, 12.5 times 10 is 125. And 100 times 10 is 1,000. So now we have three equivalent fractions, but we have whole numbers in our numerator and in our denominator, which is helpful before we reduce the fraction. Now we want to reduce the fraction by finding common factors. Well, as it turns out, 125 is equal to 1 times 125. And 1,000 is equal to 8 times 125. Now we have a like factor of 125 in the numerator, a like factor of 125 in the denominator. We can simply cancel those out, and that leaves us with a fraction of 1/8. So we found that 0.125 as a decimal was 12.5%, and we reduced it. We converted it to a fraction, 12.5 over 100. When we reduced the fraction, we found that was equal to 1/8. And we will move on, do the next piece here. A lot of practice problems here to do today. We keep going back and forth in different directions because we want to help you to see exactly how this all ties together and try to make it make sense and be intuitive to you. So what we're going to do now, we're going to take some percents. We'll start with 60%. Then we're going to change that to a decimal. Remember the rule, percent to decimal, move the decimal place 2 places to the left. So this simply is the same 1/2 as 0.60. There's our decimal version. To make it a fraction, let's just take this 60 over 100. That is the rule for percent to fraction. Make the denominator 100. Well, that's equal to, what do we got here? 3 times 20 is 60. 5 times 20 is 100. So we've got equivalent, still an equivalent fraction. These multiplications make the numerator and the denominator to be unchanged. We cancel the factor 20 that's in both the numerator and the denominator. We end up with 3 over 5. Now, these are all equivalent fractions because the ratios of the numerator to the denominator remains unchanged. Each of these fractions is equal to 60%. Here's the percent we started with. Here is the decimal version. Here's the fraction. Here's the reduced fraction. %17.5%. I believe you're probably all now getting pretty good at doing this. Decimal place 2 places to the left converts it to a decimal. 0.175. There's your decimal version. Our fraction version, put the percent over 100. 17.5 over 100. Now we'd like to get whole numbers in the numerator and denominator, so we're simply going to multiply by 10. I'm going to skip writing that out this time. I'm just going to move the decimal place 1 to the right for the numerator and the denominator to get whole numbers and the same equivalent fraction. So 175 over 1,000. So there is a fraction with whole numbers in the numerator and the denominator. this factors out to 175 equals 7 times 25, and 1000 equals 40 times 25. The like factors cancel. That leaves us with 7 over 40. Again, we have a prime number in the numerator, which helps us realize that the numerator can't be reduced further. And 40 is not a multiple of 7, so we know that there's no factors of 7 and 40. So we're in lowest terms. 17.5 became a decimal 0.175, became a fraction of 175 over 1000, reduced to 7 over 40. We're kind of doing all these from each direction to help emphasize how they all work here. We're going to do one more here. This is a little bit different. We're going to do 8 and 3/4%. Now, we have a fractional percent. The best thing to do is convert the 3/4 to a fraction, or to a decimal, and 3/4 is going to be equal to 0.75. And this is 8 plus 3/4. Well, 8 plus 0.75 is going to be 8.75 when we add those two together. So here is our decimal version of our percent. But we could also, this is just the percent, 8.75%. That's right. It's 8.75%. We converted the 3/4 to decimal, so we could add them together. So here it's 8.75% and 8 3/4%, exactly the same number. Put this over 100 because we're wanting to get it into well, let's first first convert this percent to decimal. Convert a percent to a decimal by dividing by 100. Decimal place 2 places to the left, so we end up with 0.0875. There's the decimal version of this thing right here. This is the 8.75%. There's the decimal version of 8.75%, which is 0.0875. And you notice here's the hundredths part, which is the percent part, 8/100ths, 8%, and then a fractional part of a percent. Let's convert this now to a fraction. 8.75 over 100, that's our rule. 100 is the denominator of the percent. Now we want whole numbers, so multiply the numerator times 100, the denominator times 100. That gives us 875 over 10,000. We'd like to reduce that. Well, 875 is equal to 7 times 125. We found a factor of 125 went into there 7 times. And it's 80. 125 goes into 10,000 80 times. And so we wrote 875 is 7 times 125. We wrote 10,000 as 80 times 125. We can cancel those like factors, and we end up with 7 over 80. So we started with 8 3/4%. We converted that to 8 3/4. We converted to a decimal number, left it in percent. Then we moved the decimal place 2 places to the left, divided by 100 to get a decimal value of 0.0875. Then we wanted to get a fractional value. We took the 8.75%, we put it over the denominator of 100. Then we multiplied the numerator and the denominator by 100 to get whole numbers in the numerator and denominator. Then we factored 875 into 7 times 125, and we factored 10,000 into 80 times 125. We canceled the like factors, left us with 7/80. So 8 3/4% was equal to 0.0875 as a decimal. It was equal to 7/80 as a fraction. Oftentimes, you'll need to find out what percent of what value, say, a certain percentage of something is. So if you want to do that, first you want to change percent to decimal. To decimal. Then you want to multiply that result times the number you wish to find percent of. You're looking for a fractional percent of. So let's do a few examples of that. Say we want to find 15% of 50. First we want to change that 15% into a decimal number, which, remember the rule, percent, move the decimal place 2 places to the left, so that becomes 0.15. And now we want to multiply that times 50. Which, if you work that out, that comes out to be 7.5. So what we've determined is that 0.15 is 15%. 50 was what we were looking for 15% of. We multiplied this times 50. We found that the result was 7.5. So that says that 7.5 is 15% of 50. 7.5 is 15% of 50. Converted to a decimal, multiplied by the base that we were finding the percentage of, come up with a value. Now we rephrase it as a sentence. 7.5 is 15% of 50, which answers the question, what is, let's put that in there, what is 15% of 50? Our answer was 7.5 is 15% of 50. So let's ask ourselves another question of very similar type. What is 200% of 45? Okay, first step, change our percent to our decimal. 200%, we move the decimal place 2 places to the left to get a decimal, which gives us 2.00, or just call it 2. We'll just call that 2. So 2 is the decimal equivalent of 200%. Now we want to do the multiplication. 2 times what we're finding the percent of, 45, equals 90. So 90 is 200% of 45. We'll write that as our answer. 90 is 200% of 45. So there was our question. What is 200% of 45? We converted 200 to a decimal, which was basically just 2.0. We multiplied the 2.0 times what we're trying to find a portion of, 45. That gave us 90. Our result was 90 is 200% of 45. We're going to do one more of these type of problems. It's important. This is important. You'll oftentimes want to find out what value is some certain percentage of something. So our question here is, what is 7.25% of 40? Put a question mark on that. Well, 7.25% is also 7.25%. This represents the fractional portion. 0.25 is 1/4. We want to convert this to a decimal. We're still in percent. Move the decimal place 2 places to the left. So we have 0.0725 is the decimal version of 7.25%. Now we want to find out what is 7.25% of 40. So we've converted to decimal. We're going to take that result. We're going to multiply it times the number we're looking for percent of, which we're looking for percent of 40. 0.0725 times 40 equals, we end up with 2.9. So now we can answer our question. We can say that 2.9 is 7.25% of 40. We had a question. We need to find a certain percentage of 40. We converted the percentage to a decimal. We multiplied the decimal times the 40 that we were wanting to find a portion of. We found the answer to be 2.9. So we know that 2.9 is 7.25% of 40. Okay, so now we're going to kind of work on discounts and things like that. The question is, we have a store. Store is offering a 15% discount, 15% off on a $50 boom box. Well, the first thing we need to know is how much are they knocking off? Well, that's 15%. So we want to find out what 15% of 50 is. The first thing we do, we take the 15%, like we talked about a little bit ago, and we convert that to a decimal, 2 places to the left, 0.15. Now we want to multiply that times 50. Gives us $7.50. So we're getting a discount of $7.50. How much for the boom box is the question. We got a 15% discount. We want to know how much for boom box. So we calculated how much we're getting off, which is $7.50, by taking the percent to a decimal, multiply it times the 50 that the percent was off of. So now to get the cost of the boom box, we've got to take the original cost, which was $50. And from that we want to subtract the discount. Well, $50 minus $7.50 comes to $42.50. So the $50 boom box, after we took off the 15%, which we calculated here, is going to cost us $42.50. So there's a use why you might want to calculate how much a certain percentage of something was. Here we want to know what 15% of $50 is so we can determine how much money we were saving on buying our boom box. So when the store sells something, they usually do a markup. They've got a product, the store marks up of the cost of what their cost of $50, which they're paying for an item they're selling, by 150%. How much is the price? What is the price? Of course, very quickly, if they're marking it up, we know the price is going to be more than their cost. But they're marking it up by 150%. So we want to figure out what 150% of $50 is, so we know how much they're marking up the cost of the item they have for sale. Well, 150%, we want to convert that to decimal because we want to find what 150% of this number is. And two places to the left, that's 1.5. 1.50, but we don't need to keep that zero in there, really. So to figure out our markup, we take the decimal version times what we're marking up. 1.5 times 50 equals 75. So they're marking it up $75. Markup is $75. Seems like a pretty nice markup on an item they pay $50 for. But now we want to know the cost. This tells us how much they marked up. We still don't know what we're going to pay for the item. The price is going to be the cost that the store pays plus the markup. And the cost we were given is $50. The markup we calculated is $75. 50 plus 75, that comes to $125. So if they have a $50 cost or something, and they mark it up by 150%, that means they increase the price by $75. What they increase the price by, their markup, plus what they paid, their cost, is what we're going to pay, which is going to be $125. Not sure what this item is, but that's a pretty nice markup. It would seem like in most cases. Might even cause you to think about looking somewhere else who's willing to sell it for a little less markup. So we're going to talk about current in a resistor. Remember, this is math for electricity and electronics, so we're going to be putting in some electrical type examples as we move along. The current in a resistor is 2 amps. If we increase voltage by 15%, current increases by the same percentage. By the same percentage. So they give us some information, but we can see here that current and voltage are going to be proportional in a resistor. We double the voltage, we double the current. We increase the voltage by 15%, we increase the current by 15%. So we got the question now is, what is the new current? So the question tells us that the voltage increases 15% and that the current will increase by the same amount. So we need to figure out what 15% of 2 amps is to find our increase, and then we'll add that to our original current to get the new current. So 15%, remember the rule, convert it to decimal, move the decimal place 2 places to the left, so that's 0.15. Then we want to multiply that times what we were starting with to find out the increase. 0.15 times 2, which became 0.30 amps. Pretty easy to see, 2 times 1500 is going to be 30 amps. So we're going to get an increase of 0.30 amps. Our original amperage was 2 amps, so we got a original amperage plus increase equals the new amperage. So our original amperage was 2 amps, 2.0. Plus our increase, which we found to be 0.30 amps. Well, 2.0 plus 0.30 is 2.30 amps. So when we increase the voltage by 15%, we also increase the current by 15%. So our current went from 2 amps up to 2.3 amps. Got another price type example. We have a store that's discounting a $450 mountain bike by 1/3. $450 discounted by 1/3 by 1/3. We want to, and there is also 8.5% tax, 8.5% sales tax. So we need to find out what the discount is, get the new price, then add 8.5% to that for the sales tax, find out how much we got to pay. Well, 1/3 is already in pretty much a decimal type of relationship. We could convert that to 0.3333 repeating and multiply 0.333 by 450, but 1/3 works good too. So we're going to go 1/3 the percentage of discount, or the decimal version of the percentage of discount. It's actually like a 33 1/3%, but we're going to multiply that times the original price of $450. Well, 1/3 times 450 gives us $150. The discount is $150. We have a third off. A third of 450 is $150. We're going to get $150 off on this mountain bike that originally started at $450, or bicycle. So now we're going to take the original price of $450, $450, and we're going to subtract from that the discount of 1/3, which we found to be $150. Well, 450 minus 150, that's $300. So the price of the mountain bike is $300. But we have to find the tax. The tax is 8.5%, and 8.5% is equal to a decimal of 0.085. We move the decimal place 0.2 places to the left. Now we're going to have to take the cost, 300, plus the discount, or plus the tax. So we need to find 8.5% of this. We've found that 8.5% is 0.085. That's our decimal version of 8.5%. We're going to multiply that times the $300. So here we're going to take, this is our price after we subtracted the discount. This is our price after we subtracted the discount. We multiply that times the 0.085, which is the sales tax percent. We'll come up with how much the sales tax is. So, $300 price, we've already calculated. The sales tax, we go 0.085 times 300 comes to $25.50. So we found our discount, we subtract that to get a $300 sale price for the bicycle. We took our $300 sales price for the bicycle, multiplied it by the decimal version of the 8.5% sales tax, we come up with a value of $25.50. We add those together, we have to pull out of our wallet and hand to the clerk at the store $325.50. Write a check, your MasterCard, whatever. That's how much money we got to give them to take the bicycle home that was originally $450, was discounted by 1/3, which was a $150 discount, which came to a discounted price of $300. The discounted price of $300 plus the sales tax on $300, $325.50. Sounds like a fairly good sale. I'm going to summarize a couple things and then do one more problem here. We're going to summarize some of these things we've done. Percent increase. How do we do that? We calculate that by taking the final value and we subtract from that the initial value. We multiply that times 100 and we put the whole thing and divide it by the initial value. Initially, I read this. I can just read it. So, final value minus initial value. That's how much the increase was. If it was $125 final, it started out at $100. That would be a $25 increase. The 25 on the initial value gave you the decimal version, the times 100 converted to percent. Now we're going to do percent decrease. We're going to have these two formulas, which you can write in your notes, memorize if you so desire. Percent decrease. Very similar. Only being we're decreasing, we're going to have the initial value minus the final value being we're decreasing, final value is going to be less than initial value. We want to remain with positive numbers, so we're going to take the initial value, subtract from that the final value. We're going to multiply that times 100 for the same reason as above, and we're going to divide that by the initial value. And again, here, initial value minus final value gives you a number that represents how much the value went down. Dividing that by the initial value gives a decimal version of that. Multiply it times 100, converts it to percent. You notice we have percents over here. So we have one more example here we want to do. The resistance of a wire, again kind of an electrical example of a wire, increases with temperature from 1 ohm and ohms is the value for resistance, omega, we use that quite a bit, to 1.02 ohms. Again, the omega symbol to represent ohms for resistance when heated. Well, okay, with temperature. When we got hotter, the increases. And we want to know what is the percentage of increase. So, if we were looking for percentage of increase, let's use that formula. Well, what was our final value? Our final value was 1.02 ohms. 1.02 ohms. Our initial value, subtract from that, was 1.0 ohms. And we again want to multiply it by 100. And we want to divide that by our initial value, which was 1.00 ohms. So we want to find our percentage increase. 1.02 minus 1.0 leaves us with a increase of 0.02. Multiply that times 100. Put that over 1.0. It was increased by 0.02 ohms. We divided that by 1.0 ohms. Well, 100 times 0.02, pretty easy to do because it's times 100, 2 decimal places to the right to multiply by 100, so that becomes 2 ohms over 1 ohm. Now we can cancel the ohms because we have ohms on the top and ohms on the bottom. We can cancel units just like we cancel factors. So our percentage increase is basically 2. Now 2, that's the decimal version. Let's see. No. 2 over 1, yeah. This was percent. So 2 was percentage. So it's 2%. So when we increased the resistance of the wire, when we heated it up from 1 ohm to 1.02 ohms, we increased the resistance of the wire by 2%. And that's kind of easy to see. We have, that would be like 100 or 100 or 102 if we multiplied them. If we put them over 100, you would see the relationship there. So these are important formulas. To find the increase, take the final value minus the initial value. That gives you a positive number for your increase. Multiply it times 100, then divide it by the initial value. If we want to find a decrease, take the initial value, subtract the final value. That gives you a positive number for your decrease. Multiply it times 100, divide it by the initial value. That gives you the percent decrease. And we utilize that here. We had an initial value of 100. Final value of 102, so we put the 102 final value in the increase formula because it asked about increase, and we can see that's bigger, so we know it was increase. We put the initial value in of 1, we multiplied by 100, then we divided by the initial value. We did the work in parentheses, Then we multiply it across the numerator to get 2. We didn't have to multiply it across the denominator. We had 1. We canceled the units. We end up with 2%. I think that'll do it for today. I thank you for coming back. I hope you've taken the time to find some kind of a book to get practice problems out of. Maybe you can find practice problems on the internet. Maybe you have enough, maybe you can apply these things to things in your own life. Maybe you can look at gas discounts or sales at the stores and make you utilize this stuff. It's important to do some practice to help these ideas get more cemented into your mind as they stay with you. Remember to like and subscribe. Until the next time, keep on learning.